Nature, in its quiet and unassuming way, often holds the most extraordinary secrets. For centuries, we have looked beneath the earth, digging and blasting to find the materials that build our modern world. But it seems we may have been overlooking a remarkable partner, a silent alchemist working tirelessly in the soil. Just this month, in November of 2025, scientists have unveiled a truly astonishing discovery. They have found a common tropical fern, a plant known as Blechnum orientale, that possesses a power straight from the pages of science fiction. This humble plant has the unique ability to pull precious metals directly from the ground and store them within itself. This revelation redefines what we thought was possible for a living organism. These are not just any metals. The fern accumulates a group of elements called rare earths. These 17 elements, with names like neodymium and lanthanum, are the essential building blocks for our most advanced technologies. They are vital for the powerful magnets in wind turbines, the vibrant screens of our smartphones, and the intricate circuits that power our lives. The demand for these materials is immense, yet our methods for obtaining them have always come at a great environmental cost. This fern, however, offers us a glimpse of a completely different way forward. Imagine a world where our quest for resources does not leave scars upon the landscape. Instead of vast, open-pit mines, we could see fields of lush green ferns gently swaying in the breeze. Each leaf, each root would be performing a quiet miracle, drawing up the very elements we need. This process, known as phytomining or mining with plants, has been a long-held dream for many scientists. The discovery of this particular fern's talent is a monumental step toward making that dream a reality. It is a profound reminder that the solutions to some of our greatest challenges may not lie in new machines, but in the ancient wisdom of the natural world. The fern itself is not rare or exotic. Blechnum orientale grows widely across tropical regions, often seen along roadsides or in disturbed patches of land. It is a survivor, a pioneer plant that can thrive where others might struggle. Perhaps it is this resilience that allowed it to develop such a special skill. For countless generations, it has been silently performing this incredible chemistry, unnoticed. It is a powerful lesson in observation, showing us that even the most familiar of plants can hide capabilities that have the potential to change our world. We are only just beginning to understand the full scope of what this green marvel can do. How does this simple-looking plant achieve such a complex task? The process is a masterpiece of natural engineering, occurring on a scale so small it is almost impossible to imagine. Deep within the soil, the fern's roots spread out like a fine net. As they absorb water and nutrients, they also draw in rare earth elements that are present in the surrounding earth. But the fern does not simply store these metals as loose ions. Instead, it does something that has never been seen before in any plant. It actively builds microscopic crystals inside its own living root cells, transforming the metals into a solid mineral form. This biological process is called phytomineralization. The fern creates tiny nanoscale crystals of a mineral known as monazite. In the geological world, forming monazite requires immense heat and pressure, deep within the Earth's crust over millions of years. Yet this remarkable fern accomplishes the same feat at normal air temperature and pressure inside its delicate root tissues. It is, in essence, a miniature mineral factory, powered by sunlight and water. It takes scattered, invisible traces of metal from the soil and concentrates them into a pure, harvestable form. This is a level of biological craftsmanship that we are only now beginning to appreciate. This plant-based method stands in stark contrast to our conventional mining operations. Traditional rare earth mining is a brutal, energy-intensive process. It involves moving colossal amounts of earth, crushing rock, and using vast quantities of harsh acids and chemicals to separate the metals. The environmental toll is staggering. For every single ton of rare earths produced, the industry can generate up to 2,000 tons of toxic waste and 1,000 tons of acidic wastewater. This pollution can contaminate soil and water for decades, leaving behind barren, poisoned landscapes that are difficult, if not impossible, to restore. The fern, however, works in harmony with its environment. Instead of destroying the land, it covers it with vegetation. Its roots help to hold the soil together, preventing erosion from wind and rain. The process uses no harsh chemicals and produces no toxic liquid waste. The energy it requires comes freely from the sun. The fern simply grows, living its life. And as it does, it tidies up the soil, concentrating the very elements we seek. It is a closed-loop, elegant system, the complete opposite of the loud, destructive and wasteful methods we have relied on for so long. It is nature's own clean technology. The discovery of this fern's abilities opens up a world of possibilities for a cleaner, more sustainable future. One of the most exciting prospects is its potential to heal land that has already been damaged by mining. Huge areas across the globe are covered in mine tailings, the leftover waste rock from which most valuable minerals have been extracted. These sites are often barren and can leach pollutants into the environment. By planting Blechnum orientale on these tailings, we could potentially achieve two goals at once. We could clean up the contaminated soil and, at the same time, harvest the remaining rare earth elements. The process would be beautifully simple. We would cultivate the ferns on these low-grade soils or mine waste sites. After the plants have grown and accumulated the metals, they would be harvested, much like any other crop. The harvested biomass would then be burned into an ash. This step dramatically reduces the volume of material and concentrates the rare earth-rich monazite crystals even further. From there, standard metallurgical techniques could be used to extract the pure metals from the ash. This approach would require far fewer chemicals and less energy than processing raw ore, making it both cheaper and cleaner. This new method could also change the global landscape of rare earth production. Currently, the supply chain is heavily concentrated, with one country controlling the vast majority of mining and refining. This creates geopolitical tensions and makes the supply vulnerable to disruption. Phytomining, however, allows for a more distributed model. Small, modular extraction sites could be set up wherever suitable soils exist, even in places where traditional mining would not be economically viable. This could empower more countries to produce their own rare earths, creating a more resilient and diversified global market for these critical materials. Ultimately, this fern provides a bridge between our technological ambitions and our ecological responsibilities. The very technologies that are helping us move toward a greener future, such as electric vehicles and wind turbines, depend on these rare metals. It has always been a painful irony that obtaining these green materials has relied on such a dirty process. This fern offers a way to break that cycle. It shows us that it may be possible to power our future without poisoning our present. It is a vision where technology and nature do not just coexist, but actively work together for a healthier planet. While the promise of this discovery is immense, we must proceed with wisdom and caution. The path from a laboratory finding to a large-scale industrial process is a long one, filled with important questions that need answers. One of the most significant challenges involves radioactivity. The monazite mineral that the fern creates naturally contains small amounts of radioactive elements such as thorium. When the plant matter is burned to ash, these radioactive materials will become concentrated. We must develop strict safety protocols to protect workers and the environment from any potential risks associated with handling this ash. We must also think carefully about the ecological impact. Blechnum orientale is native to tropical Asia and Australia. Introducing a plant to a new environment outside of its natural range can have unforeseen consequences. there is a risk it could become an invasive species, outcompeting native plants and disrupting local ecosystems. Before we consider planting vast fields of this fern, comprehensive ecological assessments are essential. We must ensure that our solution to one environmental problem does not inadvertently create another. Protecting biodiversity must remain a top priority as we explore this new technology. The next steps, therefore, must be grounded in careful and thorough research. Scientists will need to conduct pilot trials in controlled environments, perhaps on contained plots of mine tailings. These studies will help us understand how quickly the fern grows, how much metal it can accumulate per hectare, and what soil conditions are optimal for its work. We need to measure everything, from the influence of soil acidity to the role of tiny microbes that live around the plant's roots. Only with this data can we determine if phytomining with this fern is truly efficient and scalable for industrial use. Despite these challenges, the feeling is one of overwhelming hope. This remarkable fern has opened our eyes to a new frontier of possibility. It reminds us that the natural world is a library of brilliant ideas refined over millions of years of evolution. The solution to cleaning our land and sourcing our materials may not come from a bigger machine, but from a deeper understanding of life itself. If we can learn to work with nature as a partner, we may unlock a future that is not only technologically advanced, but also fundamentally cleaner, safer, and more in balance with the planet we all call home.